we can find roots with MATLAB. So a good place to start, if we think it's called roots, is to look up the roots function in MATLAB. Roots returns a column vector whose elements are the roots of the polynomial c. Hey, that sounds like what we want. All right. However, we have to get a little fancy because MATLAB doesn't do this kind of math very well. This kind of math here where it's plus 10 times x, blah, blah, blah. Very much like the linear systems, we took out the variables and left the coefficients. We worked with the coefficients. It's going to be the same formatting here, and you can see it in the example. So the example in the help menu is very helpful in this case. Here's a sample. I want to find the roots of a cubic. What I define are just the coefficients of the cubic. Obviously, they come in some order, and MATLAB understands that you've put your coefficients in the same order it's expecting, and then it can find the roots of it. So let's find that order right off the bat before we go back to the code. Do I put the coefficients in the order of highest power to lowest power, or lowest power to highest power? High to low. OK, so the first one should be the highest power of x in our case. That's perfect. Let's go back to here, close our help menu. Thank you, help menu. And find the impact point using roots. All right. So we're going to say our polynomial is the coefficient of the quadratic. Well, actually, we have that right here. So God bless cut and paste. Just the coefficient. Notice I'm leaving off. I'm not going to take the x squared, the s squared, the s cubed. In that other example, we left the variable off. We just take the coefficient in front of it. So we grab the coefficient for the x squared. And then we put a comma. Then we grab the coefficient for the linear term, the first degree term, just the coefficient part. And then we grab the last coefficient, which is just the constant term, y naught. And then we can say, please find me the roots of a polynomial whose coefficients are quadratic, linear, constant. Those are my coefficients. So not too bad. We already have all the inputs that we need. We're just going to run that. Oh, sorry. I should put an S in the word roots, apparently. That would be better. Let's try that. There we go. So we get our graph back, but more importantly, the new thing is down here. What did we say when we zoomed in? Well, the number is really, really close to 40. The impact point is close to 40. 39.9460. That sounds like what we saw when we zoomed in. So that's working perfectly. Of course, there's another root down at the negative side, because it is a parabola. It'll have another intersection further back, but that's fine. What I'd like to do is maybe show that on the graph. I'd like to show that impact point as a dot. But I want to automate it. I don't want to type in plot a dot at 39.944. I want to take it out of that roots thing. I'm getting two numbers back. Which of the two do I want? The highest. Hey! What have we used already to find the highest? X, exactly. So what we can say here is the impact x is equal to the maximum, the largest of the roots of that polynomial. And then we can add another plot command. We can add a plot of at the x location impact x, at height 0, because the ground is at height 0, and we can make it a big red dot. Marker size 16. Try that. Make sure that works. Lovely. A little small, though. Let's go with 30. That's better. OK. Sorry, I'm trying to get that out of the way for you. That's some code that'll do what we want to accomplish for this particular step. And the nice thing about this is it's generic code, right? I can go back, and it'll work on any launch that I care to talk about. If I want to increase or decrease the velocity down to 10 and rerun it, I'll still see the impact point. I've got a little bit of spurious stuff at the end there, but we can tweak that. We can go to 15. We can see what the impact point is. It's doing all this stuff automatically based on the new inputs. All right. Run that one more time and go back to there. So that's not bad. We've solved our first nonlinear equation, and we've solved it in a general case in the sense that we can plug any trajectory in here and get the impact point.